Hi everybody, welcome to the Manifold channel. Today we're going to do the first video in a series of videos comparing Manifold System Release 9 to ESRI's ArcMap running Spatial Analyst. We're looking at the ArcMap desktop right here, and this is the ArcMap Standard Edition, which sells for $2,750 per seat. And to add Spatial Analyst to that is an additional $2,500. So we're looking at we're looking at over $5,000 worth of software per seat. And what we're going to do is we're going to compute streams, that is Watershed Lines, using this raster here, Florida. It's a terrain elevation raster, Florida, which is 5,300 pixels by 5,300 pixels. To compute stream flow using Spatial Analyst is a four-step process. First, you have to compute flow direction, then you compute flow accumulation, then you do a set null on flow accumulation, and then you can do a stream to feature conversion. In Manifold, all that is one step. Here's Manifold, which let's click into Manifold, which you can buy Manifold Universal Release 9 for under $500, typically $450 to $475. And this is exactly the same raster here. It's formatted the same, so you can see it's the same deal, same in Florida. This is the actual Florida raster that we're using. It's styled a little bit more beautifully. The grayscale is something you can do in Manifold where you can have multiple visualizations of exactly the same data. So let's get right down to it. It's a one-step process in Manifold, and I'll kind of give the game away right away. Manifold can do in seconds what takes Arc minutes. So let's first do it in Manifold, and we'll do it really quickly in Manifold. Then we can come back to do it in Arc. The Transform toolbox is analogous to geoprocessing tools in Manifold, and there's lots and lots of them that can be done here. And there's so many of them that it helps to use the filter box to reduce it just to what you want to see. So we're going to compute watershed lines with a minimum flow of 100. And let's do it. Click Add Component. It calculates. And like magic, it is already done. If we take a look at what it did, it created this drawing right here. Let's drag and drop that drawing into our map. And you can see that there's a whole lot of very small lines because, after all, this is Central Florida. And even in the Lake Wales Ridge region, which is the highest part of Florida, it's still pretty flat terrain. So watersheds and watershed lines aren't all that dramatic. You'll see that Arc creates exactly the same sorts of features. How long did it take Manifold to do this? We can see by looking at the View Panes log window and scrolling down here to the end. And you can see it took it 3.9 seconds. Let's call it 4 seconds. Let's turn off the log and let's turn that back off. And now let's see how long it takes Arc to do it. With Manifold, as you can see, it was a one-step process. With Arc, it's going to take longer, even though we're using a considerably more expensive tool. Spatial Analyst tends to build intermediate things like flow direction, which we're going to build first. And let's get this cooking so we can talk about this stuff. Whoa, cancel. What do I want to do here? Default surface raster. I want to use Florida Grid. Let's double-click on Florida Grid. And everything else is going to be default. Okay, it's off to the races. We've set the parallel processing environment here, the geoprocessing factor, to 100%, which means that Arc is making its own decision how many parallel threads to launch. And it's running 9 parallel instances. This is going to take, by the way, about 1 minute and 23 seconds, so we have some time to talk about what's going on. What we're running on, the machine we're running on here is a Threadripper with 24 cores, which could run up to 48 threads. Why Arc decided to use only 9 parallel instances, well, I don't know, but that's what it decided to use. It's entirely up to Arc. When Manifold ran in that slightly less than 4 seconds, it was running all 48 threads. So anyway, this is just the first step of the process. The way you often do things in Spatial Analyst is that you do one step, an intermediate data result, then you do another intermediate data result using what you did before, and then you use what you just did the second time to create what you finally want. This is a pretty nice feature of Arc, by the way. Here it reports everything that it's doing, which is great for collecting metadata. Okay, it should be done any second now. We're waiting. Okay, we're waiting a little bit more. It's still going. It's telling you it's still working here. Flow direction. And come on, guys. All right, iteration phase. So it's going to be done really soon now. Completion phase. Any second, it'll be done. Now the whole process is going to end up. Oh, there you go. It succeeded, and it took it how long did it take? It took it 1 minute and 23 seconds, exactly as predicted. Great. Let's go step right along here and let's do a flow accumulation. And we're going to create that based on the direction raster that we just did. And the input weight for the raster, we don't need to do anything like that. We're just going to use defaults and click OK. All right, and we're off to the races again. So let's do flow accumulation. This is going to be a lot quicker. This is only going to be at 40 seconds. Now you might want to ask, how is it that Manifold is so much faster than Arc? The reason is that Arc is not really fully parallel. If you look at what it's doing here in the catalog when it launches these so-called parallel tools, well, they are parallel modules, but all those parallel modules are communicating through this single-threaded application, because ArcMap itself is not parallel. So every time it goes back and forth, that's a big delay. That's deletion. That's the delay number one. The second delay, okay, we're done. We're now at 37.5 seconds. That's pretty good. So we're up to about 2 minutes worth of geoprocessing. The next thing we need to do is we're going to use set null. And let's see, it's up here. And I'm going to set null on the flow accumulation raster. And the expression is going to be value less than 100, because we're looking for streams with flow accumulation of less than 100. Let me make sure I'm doing this right. Okay, input false raster is going to be, our constant is going to be 1. Click OK. And this is going to go very fast. It's only about 6 seconds. There, it's done. And now, last but not least, we're going to do a stream to feature to calculate the streams. And that's up here in the conversions. So, actually, excuse me, it's down here in hydrology. Stream to feature. And the input stream raster is the set null that we just created. And the flow direction raster, we're going to recycle this flow direction raster that we use. Click OK. And that's going to go very quickly. That's just a matter of seconds as well. Start time, start time, start time. It's going to be done any second now. Excuse me, it takes 30 seconds to do stream to feature, because there are a lot of streams here. And the end result of all this is going to be that it's running, 3 minutes, something like that. Let's zoom in here. And you can see that it creates all these little vector lines, just like Manifold did. And let's go back a few steps. And if we click back here in Manifold to take a look at what the watershed tiles look like, what the watershed lines look like in that same area, you can see they're exactly the same. They're exactly the same lines. In this case, they're default colored black. So what we've seen here is, in terms of workflow, Manifold used a single one-click transform function, Watershed Lines, and Watershed Lines automatically computed the flow direction. It automatically did everything else that was necessary. It automatically found those streams, and it did the raster to vector conversion to generate these lines all in one go. So that was just one instantaneous thing. Arc did that in a series of 4 steps. So we computed flow direction, then we computed flow accumulation, then we computed set null, then we did streams. And the parallelism here varied from 9 threads to flow accumulation was 4 parallel instances to streams was no parallel instances. And the result is that Manifold did in, what was it, 4 seconds, what 3.9 seconds, what Arc collectively took about 3.5 minutes. And the reason Manifold is faster is that first, Manifold is fully parallel. Everything that's going on here is happening in parallel all the time. Manifold itself is a parallel application, so it's not dispatching to some external tool doing a round trip between a non-parallel application and a parallel application. It's all parallel all the time, which goes for a lot of optimization. Second thing, and just for the fun of it, let's repeat what we did so we can watch Manifold cooking with 48 full threads. I'm going to delete this drawing that was created. And now let's rerun that transform, Watershed Lines. Ready, click go. And now you can see here popping open. It's already done already, so it's not much to look at. But even though it was only like 3.5 seconds or 3.9 seconds, you can see all 48 cores here, all 48 threads, hyper threads were running full bore to do that computation. That's not easy to do, and that takes a lot of parallel action. It takes a lot of optimization to be able to actually use 48 threads effectively instead of just 9 or 4. And to make it go all the way parallel through, it really improves the speed a tremendous amount. The final reason why Manifold does in 3 or 4 seconds what Arc takes 2 or 3 minutes is that Arc is using GDB, which is not a particularly parallel-friendly storage mechanism. In fact, it's very parallel unfriendly. whereas Manifold is using a .map format, which is a highly effective, fully parallelized storage format. That's it's really the Radian database. It's a faster database in many respects than for spatial work than something even like Postgres, which is a very fast and very high quality database. Anyway, I hope you've enjoyed this demo. The purpose of it is not to slam ESRI. ESRI is rightfully proud for the work they've done in parallelizing a bunch of their geoprocessing algorithms, but as you can see, there's a big difference between parallel and really parallel. And going through this logjam of a single-threaded application and not really using many cores effectively tremendously slows down the parallelism, as well as using a non-parallel data store. Why did we use ArcMap here instead of ArcGIS Pro? Primarily because ArcGIS Pro wants to connect to ArcGIS Online, and that can delay the what it's doing. So to make this as fast as possible, a comparison without any risk of there being delays for internet connections with ArcGIS Pro, we used ArcMap. They're both the same price. They're still, the total cost of the software that we're looking at here from ESRI is $5,000. I hope you've enjoyed this video. Thanks for watching, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.